Yes, good evening all. Okay, so Ashish, Saad, Yash, Harsh, Charitra, Praharsh or Samir. Good evening all. Okay, so our today's topic is preparation of ethers. Yes, preparation of ethers. So first preparation is by dehydration of alcohols. So let us do first one, dehydration of alcohols. That we have done actually, but because we are specifically doing the preparation of ethers, that's why we will include it, dehydration of alcohols. Actually, when we have primary alcohol in the presence of concentrated H2SO4 at 413 Kelvin. Keep in mind, temperature is very important here. If temperature is 443 Kelvin, what would we get? Just tell me. If temperature is 443 Kelvin, what is the product formed? Tell me fast. What is the product formed if temperature is 443 Kelvin? Yes. Tell me. I kept the temperature 413 Kelvin, then we will get this product along with water. But will happen if temperature is 443 Kelvin. 443 Kelvin, then what is the product formed? Tell me fast. Swati, good evening. Yes, Sahil, very good. Then we will get ethene. If temperature is 443 Kelvin, then we will get ethene as the product. Means elimination at high temperature, complete elimination of water takes place from the single molecule. But if temperature is 413 Kelvin, then we will get ether as the main product. Very good, Harshil. Great effort. Vasant, good. Now, let us focus on its mechanism. There are three mechanisms. First, alcohol to alkene. Second, alkene to alcohol. Third, alcohol to ether. Out of these three, at least one should be asked in your final exam. Keep in mind this. Okay. So, in mechanism, you have H2SO4. So H2SO4 will give H plus ion along with HSO4 negative. So this H plus ion in the step 1, this H plus ion will attack on the alcohol. This H plus ion will attack on the alcohol. So we get CH3, CH2, O. We get protonated alcohol. Alcohol in the presence of acid we get protonated alcohol. Now, say when this protonated alcohol is formed, tell me, protonated alcohol act as electrophile or nucleophile? Yes. Good evening, Rishi. Yes, tell me. What is the nature of protonated alcohol? It will act as electrophile or nucleophile? Beta, protonated alcohol, it acts as electrophile. It acts as electrophile. Keep in mind, it acts as electrophile. Here, this alcohol attack and water is removed, and this is actually SN2 type reaction. This is SN2 type reaction, and this one is slow step. Okay, this is obviously a reversible type reaction, and it is a fast step because H plus ion will attack. But here this alcohol will attack on the carbon attached to the positively charged oxygen, and therefore it will form CH3, CH2, OH, CH2. We get protonated ether along with water. Protonated ether along with water. Can I write third step here? Yes, I will try to write here. Okay. Step 3. Now in the step 3, this protonated ether deprotonated and HSO4 negative ion formed in this ionization of H2SO4. We get CH3, CH2O, CH2, CH3 along with H2SO4. So this is a catalyst. H2SO4 is a catalyst. Okay. So tell me, what is the name of this product formed? So this is the mechanism of the reaction. Ethylene, this one. But it is simply ethoxyethane. See, this is ethoxyethane, symmetrical ether. It is a symmetrical ether. See, this one is acid-base reaction. It acts as reaction takes place. This H plus ion, it attract H plus ion, okay, and we get protonated alcohol. And now this nucleophile attack on protonated alcohol by SN2 mechanism, okay, and this is the slow step, right? No carbocation is formed in this process, okay, and sometime what happened, instead of this HSO4 negative, alcohol can be used here, and we get again protonated alcohol, okay. So small amount of acid is enough to catalyze the whole reaction. See, in many cases what happened in this step, again alcohol will be used, this H plus ion shift here, and we get this along with CH3, CH2. The protonated alcohol required in the second step can be obtained in the third step. That means a very small amount of mineral acid can catalyze the large number of alcohol molecules. Okay? Done? Any doubt in this mechanism? Yes. Okay, ethoxyethane, very good. So this is dehydration of alcohols. But keep in mind that yield of this reaction is maximum if alcohol is primary. Otherwise, if alcohol is secondary or tertiary, then alkene is formed as the major product even at a low temperature. Okay? See, the primary alcohol is needed for this reaction. If we have secondary alcohol, see, this is secondary alcohol and this is tertiary alcohol. Now, see, we have concentrated H2SO4. Now, this is the limitation of this method, okay? And temperature is 413 Kelvin. So you know, expected product is ether. Sorry. Yes, it is ether. Expected product is CH3, CH, CH3, O, CH, CH3, CH3. But along with it, we can get alkene. See, OH and one of the H. Beta elimination reaction also takes place. Means elimination product is also formed. So yield is poor. In this case, yield is poor if alcohol is secondary. You know, it is isopropyl alcohol. See, temperature is 413 only. Temperature is 413 only. So expected product should be ether. But along with that, alkene is also formed. Okay. So, what is the name of this ether? Tell me. What is the name? What is the name of this product? Yes. पाऊ में ठीक ठाक है. Yes, yes. Fast. Very good. 2-propoxy. It is 1, 2, 3, right? 1, 2, 3. It is 2 and 2-propoxy. Propane. 2 and in the bracket 2-propoxy. This is 2-propoxy propane, or we can say di-isopropyl ether. Di-isopropyl ether. Now we have tertiary alcohol. This is actually tertiary butyl alcohol. Same conditions at 413 Kelvin. So what is the product formed now? So in this case we get exclusively alkene as the product. Here only dehydration of alcohol takes place and we get ethene. Only alkene. Okay. So what is the name of this alkene? Ether is not formed in this case. Yes, what is the name? Fast. Methyl propene. Good. It is 2-methyl propene. Okay. Or common name, it is isobutylene. Its IUPAC name is isobutylene. Is it visible? Yes. 2-methyl propene or isopropylene. Okay. So that means order of reactivity of alcohols to form ether follows the order. Yes, what is the order? Primary is more reactive than secondary, and secondary is more active than tertiary, because in case of tertiary we will not get ether, we get alkene as the main product. So limitation is, in these cases primary alcohol is the better alternative. Other limitation is, what is its actual limitation? Limitation is, it is suitable to prepare symmetrical ethers. This method is suitable to prepare symmetrical ethers. Yes, it is visible, right? Okay. So it is suitable method to prepare, suitable method to prepare symmetrical ethers. Because if we attempt to prepare unsymmetrical ethers, say in symmetrical ether, it is like this. OH and H, and we get RO, R along with water. But if we attempt to prepare unsymmetrical ethers, then we get mixture of products. We get mixture of ethers, right? For example, if we have, is it possible to write? Yes, ROH and R dash OH in the presence of concentrated H2SO4 at 413 Kelvin, then we can get ROR, we can get R dash OR dash, we can get ROR dash. Okay, so these are the ethers formed in our attempt to prepare unsymmetrical ethers. So very difficult task to prepare unsymmetrical ethers. Only symmetrical ethers are prepared by this method. Okay. Second, it is very important to control temperature. Okay. So this method is suitable in industry. This method is suitable in industry because where we can control the conditions, we can have a control over temperature, we have a control over the concentration, right? But it cannot be a laboratory method because in the lab we cannot control the temperatures. Okay? So these are the limitation of this method. So this is dehydration of alcohol to ether. Now next is catalytic dehydration. In catalytic dehydration, what we do, we have alcohol, 2 molecules of alcohol in the presence of Al2O3 at 523 Kelvin. So again removal of water and we get ether along with water. Is it visible? Yes. Okay. Now this is second method. Now third, by the action of diazomethane. Can you tell me what is diazomethane? Yes, write the formula of diazomethane. Action of diazomethane on alcohol. Diazomethane. Yes. Tell me, what is diazomethane? Very good. It is CH2 and 2. So, alcohol in the presence of CH2 and 2 tetrafluoroboric acid. So, product formed is CH3, CH2O, CH3 along with nitrogen gas. Okay, so this is the product formed. Okay, now by the direct addition of alcohol to reactive alkene. Alcohol to reactive alkene in the presence of mineral acid. Okay, so what we do, we have an alkene, let us say this alkene with methanol in the presence of concentrated H2SO4. So say H plus and OCH3 added here. Obviously, this is an SN1 reaction. What type of reaction? SN1. So means carbocation is formed and then alkoxide ion attack on it. First carbocation is formed. That means if carbocation is formed, a rearranged product may be formed sometimes. Got it? Very good, Vasant, Saad, Swati. Okay, great. So this is actually Markov-Nikov addition, Markov-Nikov rule with rearrangement. Keep in mind, with rearrangement, because first carbocation is formed. Okay, let us do one reaction in which rearranged product is formed. Okay, we have CH3, 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 CH double bond CH2 and ethanol in the presence of H2SO4. So tell me, what is the product form? Alkene, alcohol in the presence of sulfuric acid. Yes. What is the product formed? We have done such reactions. Yes, tell me. Is it possible for you to predict the product? So first of all, I will explain it with mechanism. Is it? Yes. See, first of all, we have CH3, 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 CH double bond CH2. H plus ion will attack on it. So obviously H plus ion will attack on this side, because then only we get more stable carbocation. So CH3, 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 CH, CH3 positive. And you know they are releasing groups, so obviously they force pi electron to shift towards CH2. So CH2 negative, get this H plus, so we get secondary carbocation. But you know, as we get secondary carbocation, and in neighborhood there is quaternary carbon. So what happened? Tell me. What will happen? Yes, fast. What will happen now? Very good. But beta Sahil, not 1,2 hydride, 1,2 methyl shift takes place. You know, there is no hydrogen at all. Methyl groups are there. If it is tertiary carbon, then 1,2 hydride shift takes place. But as there is only methyl groups, it is quaternary carbon. So 1,2 methyl shift takes place, and now we get tertiary carbocation. 1,2 methyl shift takes place, and we get tertiary carbocation, which is more stable. This one is less stable. Okay? There is phone. Okay. Sahil, but you hit at the good point. Okay? Means you know the shift takes place. That's great. Okay. So now we get tertiary carbocation. Now on this tertiary carbocation, alcohol will attack. This alcohol will attack here now, and we get CH3, C, CH3, O, CH3, CH2, H positive, CH, CH3, CH3. Okay. So now in the next step, this H plus ion is removed, which is used here. Now it is removed, and we get is it possible to write yes, CH3, C, O, CH2, CH3, CH3, CH. Let us write CH3 here. So this is the product formed. Right? CH3, C, CH3, CH, CH3, CH3, CO, C2, CH3. Okay? So what is the name of this product? What is the name of this molecule? Yes. What is the name of this compound? Write the name. I am waiting for your reply. Fast. What is IUPAC name? Not able to write this IUPAC name? Okay, 2,3-dimethyl-2-ol-SAD. What is this? Okay, Vasant, just order should be shuffled because ethoxy comes first. So it is 2-ethoxy, 1, 2, 3, 4. 2-ethoxy, 2,3-dimethyl and butane. Okay. Where is alcohol, Saad? Tell me, is there any alcohol? Yes, 2-ethoxy, 2,3-dimethyl butane. Good, Swati. Very good. Okay, so that means its limitations, main disadvantage is it can give rearranged product. It is not possible to have the simple product. Sometimes a rearranged product may be formed. Okay, now, so to get rid of that particular thing that we cannot prepare unsymmetrical ethers by using simple ethyl alcohol in the presence of concentrated H2SO4 at 413 Kelvin, it is Williamson synthesis which can be used to prepare unsymmetrical or symmetrical ethers in good yield. Symmetrical as well as unsymmetrical ethers can be prepared in good yield by using Williamson's synthesis. For example, if we would like to prepare ethyl methyl ether, what we do? We take alkyl halide along with sodium methoxide. We have ethyl halide with methoxy, sodium methoxide, and what happened? This is removed, we get CH3, CH2, OCH3 along with NaX, and this is SN2 reaction. Mechanism is SN2. This product is formed just by treating alcohol with sodium. Okay, so we get sodium methoxide along with H2 gas. Okay, so sodium methoxide is prepared in this way. So sodium methoxide or any alkoxide react with alkyl halide to give the product. Means in general we can write Rx plus R dash X and RO and a positive to give RO R dash along with NaX. Okay, so this is the product formed. Okay, so in this way we can prepare both type of ethers, simple as well as mixed. means symmetrical as well as unsymmetrical ethers can be prepared by Williamson's ether synthesis. And mechanism is very simple, because like if this is the reaction, see we have RO negative and R dash X. So first of all, this alkoxide ion will attack on R dash. So we get R O R dash and X. Okay, this is the transition state formed, and then this X is removed. No need to do like this. Simply we get ether along with X negative. Okay, so it is one step mechanism. This is simply transition state. Okay, and reaction is SN2. So tell me, what is the order of reactivity of alkyl halides? Order of reactivity of alkyl halide. Yes. Okay, sir, no worries. Oh, Vasant, right, propane. Okay, it's okay, but just reply. Sad beta SN2. What is the order of reactivity for SN2 reactions? Very good, Sahil. It is primary, secondary, and then tertiary. Means order of reactivity. Means its limitation is alkyl halide should be primary. Order of reactivity of alkyl halides is primary, secondary, and then tertiary. Okay. For example, to prepare this ether, this is the ether. Okay. So tell me, what is sodium alkoxide, okay, or alkyl halide? Yes, means you can write it like this: CH3 thrice CO CH2 CH3. So tell me, which alkyl halide we have to use? There are two options. Either we use CH3 O CH3 CH3, this along with, right, or CH3 CH3 CH3O X along with sodium salt of, yes, these are the two reactants. So which reactant are preferred one? Tell me. Yes. Very good. First wala is very better, because here alkyl halide is primary. So sodium simple product formed is this one. But if we use this, then it will not act as a nucleophile, it acts as a base. Because of sterically hindered carbon, it acts as a base, and therefore the product formed is, in this case we get this product because it acts as a nucleophile. Okay, but in this case major product formed is this along with CH3, CH2, OH and NaX. Okay. Yes. Got it, beta? Say, in this case we get ether, in this case we get alkene. If alkyl halide is tertiary, we get alkene. If alkyl halide is primary, we get ether. And if alkyl halide is secondary, we get mixture of ether and alkene. For example, if we have CH3, CH, CH3Br, okay, along with CH3, CH2, O negative and Na positive. What are the products formed? Tell me. Yes. So first it will attack here. So we get CH3, CH, CH3, O, CH2, CH3 plus CH3, CH double bond, CH2, propene and this ether. What is the name of this ether? Tell me. What is the name of this compound? Ethoxypropane. Sahil, but we write it as 2-ethoxypropane. Am I right? We write it as 2-ethoxypropane. Yes, we can use it better. That we will do in aldehyde ketone carboxylic acid. Okay, very good. And thank you for adding this knowledge. Okay, so in this way we get ether as well as alkene. So keep in mind, for Williamson's ether synthesis, alkyl halide used should be primary. If we use secondary, we get ether along with elimination product. Means substitution and elimination both takes place. And in case of tertiary, only elimination product is formed. Okay? As a chief product. Okay. Now, next, tell me, if we have the sodium salt, what is the name of this compound? Tell me. What is the name of this compound? And common name of this. Write the name of both first and then we will proceed. What is the name of these two? Common names. Yes, it is sodium phenoxide. Okay, good. And what is the name of this one? sodium phenoxide. Okay, that's great. What about this common name? I need common name only. Yes. Very good, very good. It is a very good, Harshil. Saad, it is not a common name. Allyl chloride. It is allyl chloride. So when they react, you know, this O negative and this whole thing, it is like this. So what is the name of this compound? Tell me. Very good, Vasant. Beta, propyl double bond is there. So it is allyl chloride. Okay? Okay, what is the name of this compound? Yes. So it is, this is allyl and this is phenyl. So it is allyl phenyl ether. Allyl phenyl ether. Good. Got it? Now we can prepare how many methods we have done? 1, 2, 3, 4, 5, 6th method, I think. Is it 6th one? So by using dry silver oxide or anhydrous silver oxide. If we use moist silver oxide, we get from alkyl halide we get alcohol. But if we use alcohol in dry silver oxides, alkyl halide in silver. See what is the product found in these two cases. Yes. In moist silver oxide and dry silver oxide, what are the products found? Tell me. Moist silver oxide and dry silver oxide along with alkyl halide. Yes. Okay, 2 AgCl, AgI, sorry, and then side, very good. It is CH3, CH2, CH3, CH2O, CH2, CH3 along with 2 AgI. Okay, and in case of moist, keep in mind, in case of moist we get alcohol as the major product along with AgI. Very good. It is diethyl ether or ethoxy ethane. Very good. Now preparation from Grignard reagent. Let us consider we have this along with methyl magnesium bromide in dry ether. Yes, what are the products found? Very simple question. Yes, tell me. Good, Swati, very good. CH3, CH2, OCH2, CH3. Yes, in this case, what is the product formed? So, CH3 and Cl. Cl is negative here, CH3 is negative in this. So, Cl is replaced by very good, along with MgClBr. Okay, so we get methoxy ethane or methyl ether. Methyl ether. How? Good, beta, good. Very good. Okay. Now, next is physical properties of ethers. So these are methods of preparation. So lower ethers are physical state. First is physical state. So lower ethers are gases. Obviously lower members are always gases because of weak van der Waals attractions. So lower members are gases, higher members are liquids, because when molecular mass increases, intermolecular forces of attraction or van der Waals attractions increases, so they become liquid with ethereal smell. They have ethereal smell. Okay. Now structure. So they have two bond pairs and two lone pairs, just like water. Water is like this. This is methanol, and this is dimethyl ether. So because of the presence of lone pairs, lone pair, they repel bond pairs, because lone pair repulsions are more than lone pair bond pair, which in turn more than bond pair. This is the order of Vesper theory. Lone pair repulsion is greater than lone pair bond pair, which in turn greater than bond pair. So generally we say that if there are lone pairs along with bond pairs and total pairs are 4, then bond angle is less than tetrahedral, just like in water. Okay, but when we have alcohol, this alkyl group is bulkier, though hydrogen is small, so angle is still less than tetrahedral. But when we have bulkier group on both sides, alkyl groups on both sides, so due to steric repulsions, or we can say steric hindrance, which is more than that of repulsion from lone pairs, angle is more than tetrahedral. Angle is more than tetrahedral and it is 111.7 degree. Why it is more? Because steric repulsion due to two alkyl groups, or we can say two methyl group, is more than the repulsion from the lone pairs. Okay? Means steric repulsion is dominating. Yes, anybody who has doubt in this electronic structure? Subhashri Pothal, welcome. Okay, Nopi, Sahil. Okay, so this is structure. And what about boiling point? So in ethers, if we compare alcohols and ethers as well as hydrocarbons, see, this is alcohol, ether and hydrocarbon. Okay, so it is written in zigzag fashion. Okay, this is methanol, or we can write it as ethanol. Okay, so that they have comparable molecular masses. Ethanol, dimethyl ether and propane. So tell me, what is the order of boiling point? In alcohol, you can write like this. Alcohol, there is intermolecular hydrogen bonding. Due to the presence of lone pairs and heteroatom oxygen, it is slightly polar. But at the same time, it has bent structure. It has bent structure, slightly polar, and hydrocarbons are non-polar. So there is weak dipole-dipole attraction. And there is only dispersion or London forces because they are non-polar. So what is the order of boiling point? Very good. Alcohols have higher boiling point than ethers, which in turn more than hydrocarbon. But keep in mind, only up to 3. If carbon atoms are more than 3, then hydrocarbon has higher boiling point than ethers, because in ethers, due to oxygen, its structure is bent and therefore surface area decreases, and which decreases its boiling point. Keep in mind it. In only first member of ether, boiling point of ether is more than the hydrocarbon of comparable molecular mass, except that hydrocarbon has higher boiling point than ethers. Okay, done. So now tell me about solubility. Solubility. What about solubility? So, due to the presence of lone pair, lower member of ether are slightly soluble in water due to the formation of hydrogen bonding with water. So it is lower members of ether are slightly soluble in water, but higher members, because in higher members, hydrocarbon is dominating, this non-polar part is bigger, so higher members are insoluble in water. Okay, done. Now let us come to chemical properties. In physical properties, I think you don't have any doubt. Is there any doubt? Yes. If you have, then tell me. Any doubt up to this? Okay, no शक, नो कोई शक नहीं है. वेरी गुड, शक नहीं होना चाहिए. ओके, yes. So now let us focus on chemical properties of ether. So chemical properties, ethers have OC bond on both sides, because O is surrounded by alkyl groups, so there obviously there is carbon on both sides of oxygen, like simple ether, first member of ether family, dimethyl ether. So it is very difficult to break carbon oxygen bonds, because in alcohol there is OH bond, so that become reactive, but in this case on both sides they are non-reactive groups, or we can say less reactive groups. That's why ethers are least reactive. Ethers are least reactive towards acids, bases, oxidizing agents, or reducing agents. But under vigorous conditions they can give reactions. Under vigorous condition they can give reaction. Okay, so first reaction with acids. Okay, action of concentrated acids, that we have seen that when ether react with concentrated HCl. So tell me, what is the product form? It has lone pair, so lone pair will attract H plus ion, and therefore it is like this, or you can write here only. Okay, so dialkyl oxonium chloride. Yes, dialkyl oxonium is the product form. Or even if we have H2SO4, okay, so tell me what is the product form. Again, one H plus sign attached here. So product formed is RORH positive and HSO4 negative. Again, dialkyl oxonium hydrogen sulfate. Dialkyl oxonium hydrogen sulfate. Okay, so this is action of concentrated acids. Now second is formation of coordinate complexes. Formation of coordinate complexes. You know, in many cases we use ether as a solvent because ether has lone pairs, so ether can join the molecules by coordinate bond and keep them in the solution. See, let us take example of ether. Tell me, due to the presence of lone pair, it acts as Lewis acid or Lewis base? Yes. It acts as Lewis acid or Lewis base? Ether acts as Lewis acid or Lewis base? Wait. Very good. It acts as Lewis base. Okay. So this is Lewis acid. We have 3 electron deficient, and this is Lewis base. So we get this complex. Okay. Or ether in the presence of RMGX. Yes, tell me. In case of RMGX, you know RMGX. So ether form coordinate bond with RMGX. That's why RMGX is always prepared. Grignard reagent is always prepared in dry ether, because dry ether form coordinate bond with RMGX and keep it in the ethereal solution. We can also prepare it in benzene, but then tertiary amine is required, because the tertiary amine again acts as a base and that will form a coordinate bond. Okay, so that's all for the day. I'm running short of time. Already 8 o'clock. Yes, time is up to 7:30, but I forgot. Okay, it's okay. Yes, it is etherate. Very good, Harshil. Great effort. Thank you very much. Bye bye. Okay, bye bye. Bye Ashish. Bye Vasant. And bye Saad. Bye bye Harshil. Okay. Okay. I'm signing off now. Bye to all.